Alrighty, everybody, welcome. Thank you very much for coming. Thank you very much for coming. So while we're here, while we've all sat down, I want to take care of something very important before we get started. So when I say the word, would you say open source? And then we'll take a photo. It'll be great. Okay, ready? 1, 2, open source. Ah, that's so good. Good stuff. Thank you. Alors, before we get started, avant de commencer, aujourd'hui, on va parler un peu de toutes les technologies qui concernent à la gestation et le déploiement d'une architecture microservice. Alors, on va parler très, très vite. Et bien que je arrive à m'exprimer en français, je vais le faire en anglais, OK? Parce que il faut aller rapidement aujourd'hui, OK? Si jamais vous avez des questions, n'hésitez pas à me les poser en ces deux langues après. OK? Après. OK, merci. So, moi, I'm Josh. Oh. Merci. Okay, so, a little bit about me. My name is Josh Long. Thank you very much for coming. I'm happy to be here. We're going to cover a lot of code. The code is the language we will speak today. Code is very important. There are 8 billion people on the planet, roughly. Half have internet. For that half, code is the most powerful thing. So code is good. Grab that URL. And then let's go on. A little bit about me. I'm a Spring developer advocate on the Spring team at Pivotal. We're a small company with big dreams. Big dreams. I'm also an author. I've written now 5 books. I'm an open source contributor. The number one contributor of bugs. Number one. For 7 years now. Number one. Absolutely. Number one. To lots of great open source projects, and that's part of what I get to do. I'm also a video training guy. I did that as well. And I'm a Java champion, which is very similar to what I do as a Spring developer advocate. I get to speak with organizations and community members and so on, people like yourselves, wonderful people like yourselves who are passionate about what we're trying to do. And I speak to lots of organizations about what we do at Pivotal. At Pivotal, we have lots of great open source software. But the software, the open source, it's not notre raison d'être. You know, that's not why we wake up. It's not why we are excited. We don't go to work saying we're going to do open source. We go to work because we want to help people go quickly. Oh yeah. We want to help people go quickly and safely from concept to production. Concept, production, all the way through. Most organizations have a software factory inside the organization. It's a process where work starts from product management and then user experience and then developers, then testers, and then the administrators, the database, security, SAN, network, etc. And they look at this long process and it takes forever. It takes forever to go from here to there. In this world, the one we live in right now with internationalization, where software is changing everything, slowness is not an option. Right? You must go fast. And we see this all the time. What is the number one taxi company today? Thank you. What is the number one hotel company today? What is the number one for, growth, in terms of growth? What is the number one car company today? Tesla? Yep, Tesla. What is the number one video rental service? Thank you. These companies, when they started, they didn't have more money. They didn't have more people, more brains. They didn't have anything. They had speed. They had the ability to be agile. That's it. They were able to make more mistakes and fix them faster than the other ones. And now they're not number one like by this. They're number one by a lot. We say, in English, they disrupted. It's a whole other word. They didn't just compete. They killed the competition. They created a whole new category. Speed is the killer feature. So organizations look for ways to go faster. They look for ways to go from zero to finish, How do you start with an idea and then go faster? Organizations realize that if you have a small piece of functionality, something you can focus on without having to worry about the whole application, right? If you can take a small batch of work and focus on this batch of work, you can go faster. The trick is to find a piece of functionality in the application that you can take away from the big part of the application and then focus on it separately and deploy it separately. This small batch of work is a microservice. A microservice is a way of having organizational speed. It is not about runtime scale. Yes, you will get the ability to handle more requests and handle more users, but that's not the goal. Most people are not Netflix, they're not Google. They don't need to move to this architecture for the ability to handle users and requests. You move to microservices so that you can go faster, so that one team can work on this, another team can work on that, and there's not constant communication and synchronization. Okay? So organizations look for ways to go faster. They move to this architecture called microservices. The problem is there's two things that they hit very quickly. The first problem is I want to stand up a new service. I want to say, here's a new service, here's a new service, here's a new service. Most organizations, I'm sure you don't work at these organizations, I am sure, but maybe you know somebody who knew someone else who worked at an organization like this. They have a terrible wiki page, 500 easy steps to get to production, right? That wiki page is the enemy of velocity. It makes it scary to create new services and to do the right thing. So you must find a way to make that go away. Today we're going to look very, very quickly at something called Spring Boot. How many of you have heard of Spring Boot? Oh, well that's not everybody. That's it's most of us, but it's not everybody, and we're going to have to fix that. And then once you've solved the problem of standing up a new service, now you have distributed computing. Now you have lots of small services talking to each other. That's distributed computing, and you have to solve that as well. So we're going to look at Spring Cloud as a way of solving that. Now, we're going to go really, really fast. So, just hold on tight, okay? We have 37 minutes. I don't know if we'll be able to do this. We have to try. So those are my slides. Did you like my slides? I worked very hard on those. I'm not sure if you can see all that. So, okay, we're going to go to start.spring.io. This is my second favorite place on the internet. My first favorite place, of course, is production. Production is the best. If you can go to production, you should. Bring the kids. Bring your family. Production is amazing. It's better than Disneyland. I love production, and you will too. But if you aren't in production, then go to start.spring.io. If you are sad and want inspiration, start.spring.io. If you're restless and you cannot sleep, start.spring.io. This is a great place to build a new application. So we're going to go here and we're going to build a new service. We're going to call it the Reservation Service. We're going to bring in web support. We're going to bring in H2, embedded in-memory database. We're going to bring in JPA because I make terrible life decisions. JPA. I'm going to bring in the actuator. I'm going to bring in the config client and Eureka support and RabbitMQ stream processing and the Zipkin distributed tracing support. That's all. Oh, and REST repository support. Yes, yes. So here we go, REST repositories. Now I could also choose specific things very, very specifically. Here I could choose the packaging. And some people get very confused when to choose which one. I will explain very quickly because we have to go fast. If you are in the very distant, far, far away past, very, very far, then absolutely choose .war. But if you're here with me in 2016, then choose .jar. This is a big part of our personal philosophy. Make jar, not war. Again, you have options. You have choices. You should do what works for you. Do what works. Good stuff. Right on. So now, we've made that choice. We're going to go ahead and generate a new service. It's a new service here. It's a little zip file. You can use any IDE you want. Oops, got rid of all that. Hit any IDE you want. How many of you use Eclipse? How many of you use Eclipse? Great, I love Eclipse. How many of you use NetBeans? Great, I love NetBeans too. There's Spring Boot tools for NetBeans. There's the Spring Tool Suite for Eclipse. How many of you use IntelliJ? Good. Wow. Wow. Good stuff. And sir, are you here? Emacs guy? Are you? I don't see him. I don't see him. He's in every continent, every country. I don't know how. It's the same one. I don't know. So here we go. Let's build a very simple service. I will not spend too much time. We have to go very quickly. So, breathe. So, reservation service application. I'm going to make my font a little bit bigger, my friends. Don't you worry. I've got this. See? More bigger. Okay? Here we go. Now, here's my public static void main. I'm going to build an entity of type reservation, okay? It's just a JPA entity, at entity, like that. And it's going to have a primary key like this, private long ID, and another field called reservation name. This is going to be turned into a column in the database like this, and this is going to be called ID at generated value, right? So this is the pure form of our domain model. The essence, the base of our domain. It's very pure, very clean. It's so clean. But this is Java, so it's not enough. Let's add a lot of other stuff. Okay? Why, JP? Why? Come on. I can do this. There. There we go. Mira. ¿Por qué, María? ¿Por qué? O, ve. ¿Per qué, María? ¿Per qué? See? Trois langues. Anyway, moving on. We need a toString. There's that. Okay? Now we're going to save some data in the database. I'm going to create a repository here. This is a dumb object. It's what Dr. Eric Evans refers to as a repository. It's something that handles the boring reading, writing, and reading from the database. It's not interesting. Nobody will ever come to you on a Friday evening and put their hand on your shoulder and say, "Good job. Good job. You did a great job writing select all from foo, where ID equals question mark." Nobody cares. So don't write the code. We're going to let the machine do that for us here. I've got this interface. I've got an annotation to make it a REST API. I'm done. Okay? Let the machine do it. This will support finding my ID, saving, deleting, etc. Okay? Now I need to create some sample data. And I'm going to create an object called a command line runner. So I'll say dummy CLR implements command line runner. Okay, and command line runner is a callback. When Spring Boot starts, it will call run. It passes in arguments from here. So I can use this object to write data to the database. Okay, so I'm going to say private final reservation repository, and I'm going to create a constructor, and I'm going to tell Spring to give me the object in the constructor. This is the correct way to do this. You should do this always. The wrong way to do it is to do this. Every time you do this, a unit test dies. Every time. Every time. So we're going to say stream.of. And I'm going to say Spencer, my friend Spencer, and Mark, and come on. And Stefan, and who else? yeah. Oh no. Who else? Antonio. There we go. Some of my friends. That's a nice even number. 6, not 7. I want to sleep tonight. So I leave it a nice round number. So for each name, let's write a record to the database like this, okay? And then I'll say print for each and print line. And if we run this, we'll see that we should have data in the database. So I'm going to go ahead and run it, and we'll see what happens. Okay. So where did it go? Hello? Oh, it's down there. So there it is. That's the data. It worked. We have data in the database. Of course it worked. This was a demonstration. What did you think? Instead, I wanted to talk to you. I wanted to talk to you about this. This is the ASCII artwork. We have very smart people on the Spring team that worked very hard on this. It's very, very hard. It's very, very good. And I like IntelliJ. I'm a big fan, but I just wanted to talk about a feature that I think I consider a bug. What the hell? Why is that there? It doesn't belong there. Whatever. And I went on the internet and I complained and cried because that is not okay. So I'll go here. Okay? I went on the internet and I complained and I cried like all adults do when they were confronted with trouble. And my friend Jan from Germany, he responded with a message of hope. This is that message. It's going to be fine. Don't worry. We're going to make IntelliJ great again. Anyway, moving on. So now I've got this application. I can run it, right? I can go to the command line here. I can say, downloads, reservation service, right? And I can see the data, by the way, of course. Localhost, reservations. There's my data. I have a REST API. Hypermedia. See this? This is HTOS. Hypermedia as the engine of application state. It's a REST API that describes itself. Okay? Very, very powerful API. It's using Spring HTOS. So we'll see that. Remember that. Okay? Now, I can run this application, but what if I want to change its configuration? I can go into my application. I can go to application.properties. I can say server.port, for example. But I don't want to change the property in the jar. I have to recompile. So instead, I want to keep it outside of the jar. I will use a centralized configuration server. The centralized configuration server lets me handle secure encrypted information. It lets me change things live without restarting the Java process. It lets me keep things in one place so I don't have to duplicate it if I have more than one instance. And it lets me handle auditing and journaling. I can see who changed something and when, and then if I need to, roll back. So we want more than just this property file. We need something more sophisticated. So we're going to go back to start.spring.io, my second favorite place on the internet. And we're going to get a config service. Okay? We'll hit generate. And I have on my file system here on the desktop. Nope. I have a Git repository full of configuration information. So I'm going to grab that, git clone, move it to the desktop, move here, to config. And then I'm going to tell this config server to manage that directory. Okay, so I'll say config server git.uri equals $home desktop config, and I'll say that this is going to run in port 8888. And I will go to my code, and I'll say, abracadabra, you're a config server. Ta-da. Okay, now that's going to start up and be available on port 8888. My other microservices can connect to this config server. Imagine I am a microservice. My name is Reservation-Service. See? Reservation-Service. This is the name of my microservice. I connect to the config server, and I see two keys and values, reservation service and application.properties. All microservices, all of them, will see what is inside of application properties. Only the microservice called Reservation Service will see this. Server port. This overrides. It is the winner. This is the loser. Right? It's more specific. So now, and we have a message. I want to use that message. Let's go ahead and change our reservation service. We're going to say, we have on the class path here, after all, remember, we have on this class path this Spring Cloud Starter config dependency. So we're going to go to application.properties, and we'll say Spring Cloud config URI equals HTTP localhost 8888. I'm going to give it a name as well, right? So that way it knows how to say, this is my name, and I want this configuration. And this information is going to be used to bootstrap the rest of the application. So by convention, Spring Cloud looks for it in a property file called bootstrap.properties. Now, if this works, then we should see that the application is not on port 8080, it's on 8000. Remember? The config server, it says 8000. Okay? And we should be able to see this message. Let's see if that works. We'll go to the Reservation Service application. We'll go down here, say at REST controller, class message REST controller. And I'll say at value message private string message, and I'm going to create an endpoint, and I'll say message string read return this dot message. Now, I want to be able to reconfigure this live without having to restart. So I'll say that it's refreshable, okay? Or restart that, and let's see if it happens. Let's see if it works. Hopefully it'll work. I mean, I don't know. Maybe I do know. I don't know. Maybe I do. But you don't know, so it's a mystery. It's going to be fine. Come on, faster. There's the message. Oh, it worked. So let's go to the command line now. Desktop, config, atom, reservation service, dot properties. There we go. And we can see it says hello world, but this is not what we want. We want bonjour. Okay? Extra for Reddit. This is for Reddit. Okay? So my opinion is more valid. Okay? Now I'm going to say git commit minus a minus m. Okay? Git commit minus a minus m YOLO. Okay? Now, I can see that here. There's this. But here, no visual. I cannot see it yet. I can force it to reconfigure itself by sending empty HTTP post. Okay? So I say post to localhost 8000 refresh. Now, before I do this, let's line this all up. Ready? There we go. So that was the config server. Not bad. There's a lot more we could talk about, but we have no time. So now, the next thing we're going to talk about is service registration and discovery. In a dynamic cloud-based system, when you have lots of microservices, it's important to be able to talk to other services without knowing where they live, what host, what port. You could use DNS, but DNS is a bad choice in a very dynamic environment for a couple of reasons. First of all, it needs to be cached. So when you have a dynamic environment where things die and come to life again, it's hard if you have caching. Second of all, it's a dumb protocol. If I make a request and I call the service and there's nothing on the other side, I call myservice.com and there's nothing there, the load balancer is in front of 10 instances and they're all dead, my client will block. I will hang. I'll be waiting for a reply. It'll never come. Hopefully, I have read Michael Nygaard. You know Michael Nygaard? Release it, right? That book. Hopefully, I've read this and I've set a good timeout, but most people don't. So you're going to block. I want to be able to see if there's a service, and then if there is, do something. I want to also support custom load balancing. Your average Big 5 load balancer is very dumb. It has a checkbox, not a good checkbox like the one we have in Spring Initializer, bad checkboxes. It has a dumb checkbox saying, do round robin. But what about data center aware load balancing? What about multi-tenancy? What about cache locality? If I want to route to something stateful, maybe I have an OAuth token and I'm Netflix and I'm connecting to a video that's streaming. I want to pin that. I want to be sticky, but it's not a regular JSession cookie or something like that. So for all of these reasons and more, we need something like DNS. We need the table from service ID to hosts and ports. But we need something different. We're going to use a service registry. A service registry is a phone book for the cloud. There are many great service registries out there, but one that is used very often and that has been working at scale is called Eureka from Netflix. So we're going to use the Eureka server and the config client. Now, you could use Apache Zookeeper or HashiCorp Console. Those are great choices too, and it's the same abstraction in Spring Cloud. The client is the same for all three, so it doesn't matter. But this is very easy to use. We can even install an instance of it with Spring Cloud itself. So I'll go here and I'll say @enable Eureka Service or abracadabra Eureka Service Spring Cloud config. Come on. Equals HTTP localhost 8888 Spring application name Eureka Service. And we're going to rename this file to bootstrap.properties. Now, let's run it, okay? This is going to start up on port 8761. I want my microservice, my reservation service to say, hello, I'm here. If anybody needs me, this is my space, my host, my port. So we'll go back to the reservation service, and we're going to add a lot of code. We're going to add this right here, okay? And then we're going to restart, because I hate adding extra code. So now, in the meantime, that registry is here, you see? Whoops. First of all, good quality animated GIF, very good. So now, there are no services yet, but we have added the client to our reservation service. So now if we restart, we can see, or refresh rather, we can see it's now registered. Reservation service. It's on this IP, this service ID, and this port. Now we can build a client to talk to this, okay? We're going to go back to start.spring.io and build a special kind of client, an edge service. So we're going to bring in the config server. We're going to bring in Eureka Service Registration and Discovery. We're going to bring in the Hystrix Circuit Breaker. We're going to bring in the config client, RabbitMQ, Stream Processing, Zipkin Client, Zool Microproxy, web support, hypermedia support, and that'll be it. Now it's a regular kind of client, and we're gonna discover the service from our service registry, and we're gonna build two types of edge services. An edge service is a component that lives outside of the architecture. It lives outside of the system, and it takes requests from iPhones, from Android, from HTML5, from your Tesla, from your PlayStation, your Roku, your refrigerator, right? The Internet of Things creates a lot of different clients, all of which have different security, payload, and protocol-specific concerns. These concerns are, there's a lot of them, right? So you cannot change every microservice. Instead, you create an iPhone edge service, HTML5 edge service, Android edge service, and the edge service acts as the doorman. It talks between the outside world and your system, okay? So we're going to do that here. So application.properties, Spring application name, reservation-client, spring.cloud.config. Come on, URI equals HTTP localhost 8888. Bootstrap.properties. Now, the first kind of edge service is a dumb microproxy. A microproxy takes the request from the outside and sends it straight through to the back services. We're going to use the Zool microproxy. I'm not sure if you are keeping up with your Greek or Ghostbusters mythology. So, Ghostbusters Zool. This is Zool. Aww. Anyway, so Zool is the proxy from the outside à l'enfer, right? Although that's what I think. My friend told me, he said, we don't know that. We don't know. That's not fair to say. He may come from a very nice place. He might come from Hawaii. I don't know. So that's fair. So anyway, so I have now my edge service on port 9999. This is my edge service. And Spring Cloud will set up a route from the outside to the backend microservices. So I can say, for example, reservation-service, reservations. See? Edge service, service ID, path. Here's the actual service, right? Localhost 8000/reservations. 8,000 reservations. That service is called Reservation Service. And here's the edge service. 9999 reservation service, reservations. It's being proxied. Very, very convenient. If I have HTML5, I can add SSL, HTTP basic, or OAuth, maybe I'm done. Sometimes, though, you need to change the data that comes back. You transform the request, or you transform the reply. This is a different kind of edge service. It's called an API gateway. So this is a micro proxy. The other kind of edge service is called an API gateway. We're going to build one now, a very simple, stupid one, but we'll see some interesting things, okay? So we're going to go here, we're going to say at rest controller, class, reservation, API gateway, rest controller. Very, very, very short. Mappings, and I'm going to say, whenever somebody calls this endpoint, whenever somebody makes a request to this endpoint, at /9999 / reservations / names, we're going to send them the names, not the reservation object, right? So only this here, not this, just the name, all of them. Okay, so we're going to build a very simple one, but I need to make an HTTP request. Now, I'm going to do something sad, so look away. Sad. Anyway, I'm going to use the Spring REST template, right? So I say private final REST template, whoops, like that. Create a constructor, annotate it like this. And then here, I need to make sure that my REST template is smart and that it can load balance for me. That brings up a great question. Which instance is this using? I'm making a request. I've only got one right now, but what if I have 10? Which instance? This is being handled by something called Netflix Ribbon. Ribbon is a client-side load balancer. It is a comparator, basically. It does eeny, meeny, miny, mo. And it picks the instance and it makes the request for you on the client, not on the server. So this is already happening here. You call this, it goes to Ribbon, Ribbon talks to Eureka, it gives you a host and a port, and the request goes through. We want the same thing in our REST code, our REST client. So we're going to build a load balanced REST template. Okay? Return new REST template. Okay, there's that. And now I've got this in place. Let's go ahead and build a very simple call. I'll say this.rest template exchange HTTP reservation -service. Service ID, not DNS. Okay? And it's going to be an HTTP GET, no body, and the data that I want to come back is going to be called the collection of resources from the Hypermedia API with a payload of type reservation. See, reservation. I'm going to say class reservation, private string reservation name, create a getter. There's this. And then once I have this, I can say I don't want the status, I don't want the headers, I want the body, I want the content, I want to stream over it, and I want to map, right? From reservation to the reservation name. Now, let's see if this works. I'll create the client, I'll drink some water. It's really hot, like, whew. Okay, so let's see if it worked. Come on, there we go. So a very simple edge service. I made a client call to another service. I did a simple transformation. But what happens, we know what happens if there's one instance. Everything is fine. One service, this will work. 10 services, this works. What about 0? Boom, right? It's not going to work. If there are 0 services, it's going to throw an exception, and my iPhone user is going to get a big fat stack trace, right? That's bad. So we need to be a little bit more failure tolerant. We're going to use a circuit breaker. Do you know what a circuit breaker is? Romp circuit, something like that? Coupe circuit, yeah, that. Okay? It's going to prevent failure. If there's too much electricity, it'll open the electricity. It'll open the circuit. That way, you lose the lights, which sucks. Thank you, merci mille fois. Huh? You lose the lights, which sucks. But at least you have no fire. It's much better to lose the lights than to lose the building. So we use a circuit breaker, Hystrix. Hystrix from Netflix, okay? So we're going to use that, and we're going to say, that whenever somebody calls this method, we want to have if something goes wrong, if there's an exception, we're going to create a fallback method, right? So this is going to be the fallback method. And this is just going to be simple, very, very simple. We're going to say, whenever something goes wrong, call this fallback method. Netflix does this kind of thing all the time. They'll say, oh, you called the search engine, but there is no search engine right now. It's on vacation. So here is some machine learned recommendations instead, right? It gives you something. It's better than nothing. That's important. And in a distributed system, things will die. Like taxes and death, system failure is a guarantee in life, okay? So you must build your system to be tolerant of this stuff. So that's what we're doing. Now, what about a write? What if I want to send a message to the edge service and then to the downstream service? What do? How do I circuit break a write? I can't, right? I need to take the data that comes in. I can't just go blah and just puke it on the floor. I have to do something even if the service isn't there. So I'm going to use eventual consistency. I'm going to use messaging. I'm going to use something called Spring Cloud Stream, which lets me connect services using message brokers, okay? And it's declarative. So I'm going to create a new endpoint here. Public void write at request body reservation. And I'm going to say at request mapping post, right? Nope. Okay. Value equals, oh, you don't need a value actually. So it'll just be a localhost 9999/reservations. It's a post. Now, what am I going to do? I'm going to write it into a Spring Framework message channel, a Java util queue, basically, you know, push pop. So we'll do that. We're going to create a queue that is connected to a broker automatically by convention. We're going to say that it's going to be a message channel called output, right? We can define our own interface like this if we want. I can say, CRM, and then I can have one for customers, right? One for orders, one for products, etc. I can do that, but in this case, I've only got one service, so I don't really care, etc. So we're just going to use source, okay? It's already provided for us. We're going to look at the configuration later, but all we know right now is that we have a channel, it's called output. Who knows where it's connected to? That's outside of the code. It's configured thanks to runtime, okay? So now that I have this, I can inject the source here. I can say at autowired private source output channel source, okay? And I can say this dot output channel source dot output, and this gives me a message channel, okay? And then I say channel dot send. I'm going to send a message. What kind of message? I'm going to use a message that has the name of the reservation that has been sent on the client. So I'm going to send JSON, and it's going to have a new reservation name. And I'm going to write the message to the downstream reservation service using RabbitMQ, right? I have something called Spring Cloud Stream. Stream RabbitMQ. But I can also use Kafka or Redis or whatever. I just changed the dependency here, right? By default, this is publish, subscribe, broadcast, one to many. So we don't want that. We want point to point. Let's do the same thing on the other side here. We'll say enable binding sync.class. Sync is the thing that receives a message, right? Input. You can do your own interface as well, but we want to take a message in. And we're going to say message endpoint class reservation processor. And we'll say service activator input channel equals input public void accept new reservation string rn. And then we're going to inject the repository to write the data to the database like that, okay? So this is the service side. Okay. All I'm going to do is write data to the database. So this is the service. Let's go ahead and restart it. I'll drink some water. You can sit there. It'll be fine. This is declarative, right? So when the message comes in, this method gets called. And then we do the same thing on the other side. We're going to send a write and do a read. So let's do the reservation client. Restart this. 5 minutes. Oh, this might take 7 minutes, okay? So just hold on. I'm gonna try and, ta-da, at the end, but we have to go fast. Okay. Did it work? Did it work? So I'm reading. It's fine. It's fine, right? I'm reading. No problem. What about posting? Can I write? I'm going to send my favorite doctor, my fourth favorite doctor, okay? I'm going to send a message with my fourth favorite doctor. So it's JSON, and it has this body, and my fourth favorite is Doctor Who, number 4, okay? So I'm going to go ahead and hit send, refresh, there it is, right? So I'm able to read and write, that's fine, it's good. Now what about if there's nothing there? What if I kill the service? Let's see what happens there. I'm going to go here, go to the Reservation Service, kill, refresh, it's no go, but no stack trace. I got the empty array list. Remember the fallback? And now I'm going to send my 3 favorite doctors, okay? My first 3. There's no order. It's completely arbitrary. Dr. Sire, Dr. Pollock, and Dr. Dr. Subramaniam. Oh, okay. Now, this will not work, of course. It won't read, there's no data, but it was written into RabbitMQ. So now, if I restart my service, here, you see I killed the service, we should see the data gets delivered. When the service starts, the data comes in. And remember, we wrote 6 records to the database, but it's in memory. So Doctor Who is gone because we killed the process and the data is gone, right? There we are. Dr. Sire, Dr. Pollock, and Dr. Subramaniam. They were delivered. And the reason this works is because of configuration. I'll show you this. We'll come back to that in a second. It takes a little time to finish. We have this. It says, on the reservation client, it says, Spring Cloud Stream Bindings. Spring Cloud Stream Bindings output.destination equals reservations. So remember the message channel output equals reservations. On the service side, we have the reverse. It says Spring Cloud Stream Bindings .input .destination equals reservations. So reservations, that's the rendezvous point. Producer and consumer in RabbitMQ, in Kafka, in whatever. They agree to meet there. But we also want to make sure that it's not broadcast. Only one gets the message. So we have a group. This is a consumer group. Only one instance in the group gets the message. And we want to make sure that the message is delivered even if the service is down. This is durable. So this is good. Now we've got 2 minutes. Whew. So we should talk about one last thing since we have so much time. Now, what I want to do is I want to understand how messages are flowing through the system. If I have a distributed system, I want to be able to see when messages enter and leave. This is called distributed tracing. So I'm going to use something called Zipkin from Twitter. How many of you know Twitter? It's 2016, Twitter. Okay, I'm on Twitter. I love friends on Twitter, so talk to me on Twitter. We'll be friends. I'll add you to my Twitter. So we're going to say Zipkin UI, Zipkin server, okay, config client, Eureka discovery, and then we're going to hit generate. And distributed tracing is, in theory, it's very simple. Message comes in, you add a UUID to correlate, to make sure you can match multiple messages in multiple systems. In practice, it's very, very painful. So we will just let the machine do the work for us. We'll say @enable Zipkin server. We're going to go back to here, Spring Cloud config .uri equals HTTP localhost 8888 spring.application name equals Zipkin, not Zopkin, service. Restart, rename this to bootstrap.properties. Go to Zipkin service application, start this, and then this is the service that's running again. So this is the service that edge refresh. Okay, everything's fine. Now I've started up the distributed tracing tool. That is on localhost 9411, is it? Yep. So this, right now, it knows about our requests. It knows about our services. That's the service I just created. I can hit find. I can see I made one request, right? That's right here. I just made one request. Now if I go back to this and I do another search, I'll find 2 traces, right? So I can see, for example, that if I click on this, a message entered the system from the reservation client at the reservation names endpoint. The total, that's not a good example. Let's find trace. There we go. There's 2 now. Less than a minute ago, 34 milliseconds. Yeah. So the service started, the total time for the journey, 34 milliseconds. Down here, we can see that it left the reservation client and went out to another place at this time. We can see the request log as it flowed through the system. We can see information about the host and port, and we can correlate the request. And then I can also do the same here. I can do the same for messaging. Remember this? Now I go back here, go back, hit find trace, and we see one here for the 3 spans. And you can see it says message output, message input. Output from my reservation client to the reservation service. In between, though, there's a gap. That gap is RabbitMQ, the hole. So this is one way to understand what the system is doing at large. Now, I'm really sorry that we didn't get to cover much today. I feel like if we had more time, we could have really gotten into the details. What I want you to understand is not everything that we just did. That's not the goal. What I want you to understand is that building an architecture for a distributed system is very different than what we did before, but you don't have to do it alone. This is Spring Cloud. It is being developed by people from Netflix, by people from Twitter, by people on the Spring team who have understood this, and we are integrating the best of breed components wherever possible. We want to make it as easy as possible to handle these non-functional requirements, to get rid of the wiki page with 500 easy steps. That goes away, right? Now it's all done for you, and you can build scalable systems quickly and iteratively. There are lots of great guides. Yeah, I know. It's okay. So we have guides on spring.io/guide, so download them there to get more details, okay? Thank you. Merci mille fois de m'avoir accueilli. Oh. Je peux vous demander quelque chose? Qu'en pensez-vous? Did you like it? Yes. Good stuff. Thank you very much, okay? I have to get off stage. I'll be happy to answer questions outside. Thank you. And please vote so they invite me back. They may not invite me back.